Hello my friends, welcome back. My name is Maltanan and today we're gonna do another live tutorial, so I will try to do my best not to edit it. And what we'll be doing today is a raining matrix code tutorial, which is this, what you can see right now. It is a long overdue tutorial, obviously, but you know, since I wasn't really around doing tutorials when Matrix was out, I think that works for for a good excuse. So why am I doing this? Well, I needed this raining code look for a recent promo I was doing, and the first instinct was, of course, not to barge through and bust through the open door. And I was basically looking for a ready-to-use tutorial or even a project I could download from the net. But unfortunately, I haven't found anything that would meet my requirements. Basically, the things I found were really cheesy looking. They didn't give the real Matrix raining code look. And even my technique is not as perfect as the original one that you see in the movie, but I guess it's the closest one I've seen so far. I did some tests, a couple of years ago when I was doing programming, and I actually did a matrix look using Visual Basic and DirectX. However, that wouldn't work in After Effects, obviously, so I tried to figure out how to do this. The first approach was, of course, particles and, thinking about custom particles, maybe some time remapping on the particles and such, but I didn't really get where I was going, mostly because the particles, as you know, they fall in a linear manner, so that basically they would create a line. It seems like this is a line, but this is a line in a given distance, right? Like each particle falls down a given amount, and I would like to slow this down or speed it up, be able to do that. And with regular particles, you would really have to do the math and get the math right to have the right amount of particles per second, against the velocity and all other stuff. So basically, it was really hard to do. So I tried to decompose this effect and create something that gives the same look but works in a different manner. So we're gonna do that right now. I'm just gonna save this project at a different name because I don't want to ruin this one. Let me just find the right directory. Here we go. Maltanan, tutorials, After Effects, and the Matrix. Okay, here we go. Matrix 3D was an experiment that I didn't finish, so maybe we'll get back to that later on. But now let's just call this Matrix tutorial and work with that. So I'm gonna get rid of basically everything I have here except I think this comp. Yes, it took some time to get it just right, so I don't want to waste your time watching me checking the parameters, the pixel dimensions and all that stuff. So oops, oh yeah, I must have deleted some solids. So matrix strip. Okay, this is the one, right? So we can get rid of all of these and leave this one intact. So this is the matrix strip comp. It is 10 pixels wide and 500 pixels tall. And what we have here is a regular text layer with a font applied to it, and the font is matrix code NFI, which you can download from the net. If you Google for it, you'll find it. So basically, there's not much happening in this comp. As you can see, the letters are animating. However, this is a very simple animation. I only have the animator. You know what? I'm actually going to delete it and do it from scratch. So having that done, so having the letters typed in, I'm going to click on the Animate and choose character offset, which is off screen right now. You can't see it, but it's there. So what happens when I scrub this value, basically all the chars that are in the text layer are getting offsetted by a given amount. If I change the font just for a second, you're going to see how that looks. So as you can see, we've got the C char, for example. Oh, sorry, it's D actually. And if I move it 1 point, it goes to E. And if I go negative, it goes to C. So basically, it works like that. So let's go back to the original font. Where is it? Okay, here it is. And I simply set up a simple expression to animate the charts, which is time multiplied by 2. In this case, the number might be whatever you like. However, I just found that this works best. So it changes, you know, not really rapidly, but it's a constant change in a constant time offset, basically. So we can work with that. The length of the comp is whatever you like it to be. I set it to 20 seconds, and that's it. And now let's go back for a second to the dimensions of the comp, because this is quite crucial. It's quite important. Why did I set it up like that? Well, I want to have a matrix raining code wall per se, which is going to be 500 pixels by 500 pixels. So the most important thing here is the height of the comp. If I would make it bigger, I could basically have a bigger matrix element in the end. But I guess 500 is gonna work just fine for our purposes. So let's just go to the next step, which is creating something that I've called a matrix array. So we're gonna create a new comp that's going to be 500 pixels by 500 pixels, same frame rate, so 25 frames per second, and 10 seconds long. Oops, sorry. 10 seconds. Oh, sorry, 20 seconds actually. Okay, so 20 seconds long, and that's it. I can now put the matrix strip in here and turn on the transparency grid so we can see the letters. And what we want to do now is basically copy this over. And of course, we're not going to duplicate the layers. We're smarter than that, basically. So let's just change the anchor point and the position. Why am I changing the anchor point? Well, basically, it's going to be easier for us to do it in the kind of a top left corner manner because we're going to have to calculate some things later on, like where the particles should fall and all other stuff. So basically, let's move it to 0, 0, and then the position to 0, 0. And now it lines up perfectly with the left edge of our comp. And now we can use a CC reptile effect to basically repeat it. So expand it right, and we should expand to 500 minus the original, so minus 10, so that gives us 490. And as you can see, since we did the original matrix strip comp 10 pixels wide, it's really easy for us to do the math and basically create this array. So right now this looks not really matrix looking yet. However, we're gonna get to that in a second. Now, this is the point where I should explain how this is going to work. Imagine that all those letters, all those symbols that we see here, they're animated in a certain way. They're all the same and so on and so forth. And what we're going to do now is we're going to reveal them partially with a raining look. So we're going to create some particles that are going to line up with the charts, with the symbols, and they are going to work as an alpha matte for this whole comp. This still doesn't solve the problem that all the letters are the same row by row, but we're going to fix that as well using an effect that I haven't really seen being used in other tutorials, basically. And it is a great effect that I use from time to time, to be honest, not so often, but it is a great tool, so I just wanted to show you that, and maybe you can benefit from it as well. So, having this done, we're going to create a new solid, and we are going to create a map that is going to offset our chars. So I'm going to apply a fractal noise, or even better, turbulent noise. And why is that better? Well, in CS5, turbulent noise is basically the same as fractal noise. However, it is GPU accelerated and it works much faster. The only difference is that it doesn't have the looping option as the fractal noise has. So just in case you didn't know that, it's a great tip. If you need fractal noise as a background generator or whatever it is that you use it for, and you don't need the looping of the fractal, use turbulent noise instead. It's way better. So that's that. We can increase the contrast, I believe, just a tiny bit, maybe to up to 200. And now we're going to apply the mosaic effect, and this is crucial because the shades of gray are going to tell the time offset filter how much do we want to offset each area of the image, of the effect, of the layer. We need to have those pixels, those shades of gray, lined up with the letters. So I'm gonna apply the mosaic filter now, so you can see where I'm going with this. And now we need to calculate how many of the letters we have here, and it's quite simple because we know the comp is 500 pixels long. Each column is 10 pixels wide, so that would give us 50 horizontal. And how many do we have vertically? If I remember correctly, it's around 30. I'm just remembering from the last time I did this, but it's, if you don't know, you can just simply go in and calculate how many letters there are in here. So that's that. And this should be fine, I guess. We can also animate the evolution parameter over here. So I'm gonna type in a simple expression, time multiplied by 100 maybe. Let's see how that works. Okay, so right now each shade of gray is going to offset the time on the underlying layer. So no, that's too slow. Maybe a little bit faster. 400. That should be way better. Let's see. Okay, so I'm going to go ahead and pre-compose this, and I'm going to call it readTime map. And I'm going to turn it off and put a time displacement effect onto this layer. Oh, yeah, unfortunately it doesn't work like that. So instead, I think we're going to create an adjustment layer and put it on top of everything. Okay, like that. And we're going to use the readTime map for the layer. And as you can see, we already get some changes in the whole look. However, they are not as strong as I'd like to. First of all, we can set the time resolution to 25 frames per second to match our comp, and we can increase the time displacement to maybe -10 seconds or something like that. Okay, and now it starts to look a bit better. As you can see, the letters are changing, the symbols are changing, and we are going to use that. And they're not changing in a linear manner, which is really important because some letters are gonna stay, some are going to change, some are going to change a bit later, and it's all gonna happen in the same column basically. So this is exactly the matrix raining code look. So as you can see, that's how it's working at the moment. So I think we can save this as a matrix array, and we are now ready to put it in a new comp and create a new solid, and we're going to apply particular to it. So let's just go ahead and put our particles in, we can turn off the visibility of the matrix array layer for now and turn off the transparency grid, because now we're going to work with particles, so we're gonna be we want to be sure what they do. First thing is to set up the emitter. So we're going to go into the direction and change it to directional, and now the particles are basically going towards us, and I want them to go down basically. So we're going to move this to -90 degrees, and we don't want them to spread, we just want a single line of particles. So we're going to set the velocity, direction spread to 0, and that's that. We can also put the particles higher, and we need to change the velocity. We can increase the velocity or decrease it. We can also randomize it, which is going to create a nice look later on. And we can also change the life of the particle to be maybe 5 seconds or something like that. It's really hard to tell what's going to work. But the good approach with this technique, as opposed to just using particular to create those symbols, is that this is exactly what I was talking about. See how this dot moves very tiny amounts. So if we would like it to basically move in a grid manner, we'd have to match the velocity and basically all other parameters, along with the lifespan, along with the particles per second, to have the exact raining code look. And with this technique, we don't have to worry about it, because this is just going to be a luma mat. So basically we're going to have different variations in speed in which the letters are falling and all that good stuff. So let's try maybe decreasing the amount of particles. Okay, that's good. And also we do have, of course, the grid emitter in here, but it wouldn't meet our needs in this case as well. So instead, I'm just going to randomize the X position of the emitter, and this is going to allow us to create this falling particles along the top edge. So I'm just going to alt click on the position XY, and I'm going to say math random, and it's going to be from 0 to 49, I think, times 10, and the y value, should be 0. And let's see how that looks. Ooh, something doesn't work. Let's see. Oh yeah, math random is undefined, of course. We should do it math round and then put the number inside. I guess this is going to work way better. Okay, but something is wrong. I think this is the velocity from motion parameter. If we set it to 0, we should have different dots falling, and this is exactly what we want. So now we can increase the particles per second to about maybe 100, or pretty much whatever we like. Maybe 20, that was too much. Okay, let's see what else. Theoretically, we don't really want particles falling on the 0 point. We should start from like 5 pixels from the edge, and that's why I have it set to 49 in here, because we're going to start from number 5 and then 49 times this way we're going to end up here. So I should also have it say 5 plus this, and this should be just fine. Do we even get something on this very edge? I don't think so. I only see them falling in here. They do fall down here, but they don't do it over there. That's interesting. Maybe we should not use the round, but maybe floor. Let's see. Okay, now we have it here, but we probably don't have it over there. Yeah, so let's just move it up to 50 and that should fix the problem. Okay, yes. So now the only thing left to do is to increase the size of the particles. As you can see right about here, for example, the particles are not big enough. So we can go ahead and just increase the size so that they meet like that. And that should be just fine. And okay, I think we can leave with that, but also we need to add a Aux system, which is going to emit continuously, same as main particles. And we are going to set the color overlay to a simple gradient from maybe gray to black. And we should also increase the size of the particles and increase the particles per second. So we basically end up with lines that look like this. Also, we should probably change the blending mode maybe to add. That looks better. And also we should change the blending mode in particles in here, so to add as well. But now we have too much of white color in here, so we can either change the particles per second parameter, but as you can see it causes this nasty effect in here, which we don't want. So we could also change the gradient color or the opacity. But before we do that, we can apply the mosaic effect again. And let's see if this is going to fix it. Let's check the sharp colors on, set it to 50 by 30, and let's see how that looks. Okay, this is somewhat the look that we're after, but I'm not really sure if that's exactly it. So maybe turn off sharp colors. Okay, that's better. Okay, you know what? After all, I think this is going to work. Take a look at this area, for example. We've got two particles falling in the same column, and we have this one which is slower and this one which is much faster. And this is something that would be really hard to achieve using just particular to emit all those matrix symbols. So instead, again, we're going to use it as an alpha matte. So having that done, we can now, since this is still transparent, we can now use the solid composite effect and put it on a black background and use this, which we're going to pre-compose and call it matrix particles. And we're going to use this as an alpha matte to this. Sorry, as a luma matte to this. So F4, track matte, luma matte particles, and just take a look at this. This is exactly the look we were after. As you can see, the letters are changing as they are falling, so it's exactly what we wanted. So let's call this matrix rain, and now we can put the matrix rain comp into our final composite and stylize it. So in order to do that, we're just going to use the fill effect. We can also turn the transparency grid off, set it to green, and apply maybe a little bit of glow. Play with the parameters. It's just, you know, it's just real fun right now. We don't have to worry about nothing else. So that's it. I hope you've liked it, but it's not the end. I just want to go back to the original project I showed you and talk about a few other things that are also quite interesting. So let's leave this. Again, let's just take a quick look at the final result. Maybe the letters are changing a little bit too fast. So basically, if you want to change that, you would have to go into the time remap and basically change the fractal in here to maybe 200. And you can also, increase the contrast, decrease the brightness, do all that stuff. And this changes the way the letters are swapping. And if that's not enough, you can also go to the matrix particles composition and play with the particular settings as far as velocity is concerned and all other parameters. So I think that's a cool technique. So let's take a look at how that changed the way the letters behave. They are changing a little bit slower right now, so I guess that's cool. You can also play with the levels in the matrix particles, or basically with the colors of this gradient. So you have a really distinct difference between the leading letters and the letters that follow. So basically this trail. This is where you would do all the changes. So that's it. Let's just open up the original project, which I'm going to provide with this tutorial as a download. I can see that I've named the comps a little bit differently in here, but I guess you're gonna figure out which is which. The only thing that someone might have against it is that actually in the original design from the movie, the leading letters were sometimes white. And how do we do that? Well, since this is all somewhat procedural, we basically just animate particles which are generated as well as the fractal in the time remap. We can do all the changes we like in a given pre-comp, basically, without going into those things. So let's just delete this layer, which is the layer that did the small change I was talking about, and turn on the transparency grid. What we have here is basically the same thing that we did a second ago. We've got fill, which stylizes the letter. We've got the glow, which makes them glow. No surprise there. But what do the CC Tiler and CC Composite do? Well, when I was doing this for the promo I talked about, I figured out that I would probably need a little more particles at some point. So of course I was animating the particular particles per second parameter, but also I figured that maybe if I apply CC Tiler with which is set to scale things to 50%, I could, with animating the blend with original parameter, create this look, right? Basically, it just, as you can see, it scales things down and loops the original layer. This is what the CC Tiler does, and it was perfect for this case. So I was basically, at a given point, I was adding more particles, making everything more dense, but you would see that the particles get smaller, which was something I didn't want. So that's why I added a CC Composite on top of that, so I could blend it with the original layer. And this is the final look that I got. This is still the first original layer working in here, and now the blend with original parameter is going in, so you can see all the small raining code chars showing up slowly as they fill up the entire screen. Of course, you can kind of see the edges here, but it all happens so fast that I guess it's up to you whether you want to leave it like that or just try a different technique. However, I think this is quite cool. So that's one. And the second thing is to create this leading white chars. So how do we do that? The easiest way would be to duplicate this I'm gonna turn this one off for now and get rid of those effects in here, and actually all of the effects, I don't need them. We can turn the transparency grid back on, and what I want to do is to play with the alpha channel, so I can sort of trim out everything that is semi-transparent and leave only the letters that are fully transparent. Unfortunately, it is really hard to pinpoint the exact values, since we have particles that leave trails that then get mosaiced, if that's a word. So it's really hard to pinpoint the exact values. So instead, I figured I would go with the threshold effect. Unfortunately, it doesn't work with the alpha channel. And besides, if I would like to play with levels and other stuff to make this happen, it would be really difficult. So instead, I just figured, okay, we're just gonna do a solid composite with the color black, and we're going to add a fill effect on top of it with the white color. So again, we're going to sort of have a luma matte, but instead of doing a luma matte, we're going to blend this in the additive mode. So right now we have a flat, non-transparent image that we can treat with all the effects that we want, either glows or threshold or levels or whatever you want. So basically, let's apply threshold, just like I explained in a second, and right off the bat, we have the look that we're after. Even though the letters are not 100% exact to their original form, this will do just fine for our cases. So we can just apply some glow to it and maybe increase the glow intensity like that. And I think this will do just fine. So right now we're just going to turn the underlying layer on, which just as a reminder is the original layer, and we're going to blend it in the additive mode like that. So as you can see now, easily enough, we have random letters showing up as white, basically glowing even more intensively than they originally did. So I guess that's it for this tutorial. I hope you've enjoyed it and that you're going to consider using the time difference effect from this point forth. My name is Maltanen. Thanks for watching. Enjoy the download and see you next time. Happy After Effecting.